chairing the next session, which is travel behavior, mode choice, and mobility trends. Fortunately or unfortunately, depending on how you look at it, our first speaker was unable to attend, and I don't believe uploaded a presentation. So we have a little bit of wiggle room today. So we'll maybe start with our second speaker. Rezwana Rafiq, are you in the room?
She's not here. I think she's
Oh,
on a recording. I'm here. I'm a co-author, but
perfect. Yeah,
I,
yeah, I think you made us into recording.
yeah, I'm
Okay.
unfortunately not ready to present, so I think we could use the recording and I can answer the questions.
Sure, sounds good. So she's currently a assistant project scientist in the Institute of Transport Studies at University of California, Irvine. Received her PhD in transportation sciences from UCI, and her research interests lie in the area of complex travel behavior, transportation data sciences, shared mobility, and sustainable transportation systems. So Priyanka, if you could share the recording for that one.
Yes, I'm on it.
Okay. Just while we're getting that up, I'll just note that as a Canadian, I'm very pleased to see that we have two presentations in this session from Canada. So we've had a low turnout from Canada in the past, but now I've moved back home and
I guess the Rafiq's presentation starts in presentation mode, so it's not a media player.
okay.
I'm unable to share it. So it's working on my end.
Okay.
Mm,
So sorry, it's like it's a PowerPoint with the recording.
yeah,
Yeah.
yeah.
Okay.
So I cannot share my screen at the same time when I'm running it on my desktop.
Oh.
Uh, mm.
Can't can't you share your screen with it non-full screen and then make it full screen?
Let's see. Yeah, it directly goes into the full screen.
Hmm.
Let me try the next presentation if it is working. Yeah.
Sure.
So
Okay.
I do have two recordings. So one is from Paulina Hook. So that is
Okay.
working, but not Rafiq's.
Hmm.
I think the file type is different.
Let
Okay, well
me.
maybe we could start with let's just we'll move on to Hamid Malikzadeh. Sorry about the I'm sure I'm butchering your last name, but who's a PhD candidate at Polytechnique Montreal, who started his studies in fall 2021. He graduated with a master's degree in transportation engineering from the University of Tehran, with a high interest in travel behavior and demand modeling, and he's here to present on work that was done on travel behavior during COVID-19. So I believe Hamid's here. Yeah, great. So whenever you're ready, and then Priyanka, if you can maybe we can just make I think you can make a video file out of it. So
Okay, thank you so much, Jason. So let me share my screen. Share. Do you see my screen now?
Yeah.
Yep.
Okay, good. Thank you. My name is Hamid Malikzadeh, PhD student of Polytechnique Montreal. I'm working with Professor Catherine Morency, and today I'm gonna present part of my project which is going to like present plausible post-COVID travel scenarios, travel behavior scenarios using an approach, using a pseudo-panel approach. And without further ado, I will start with our research questions. There are three main questions in our study in this part of my project. So the first one is, how have people's activities and travel behaviors changed throughout the pandemic? And the second one, what are the anticipated travel behaviors and mode usages post-COVID? And the last one, which demographic segments are associated with changes in anticipated mode use after the pandemic? So in order to answer to these questions, we have developed a methodology here which comprises of 5 steps. The first one is, in the first one, actually, we use the origin destination survey data of 2013 and 2018 in the Greater Montreal area. And we use this data to create an OD typology. In fact, we created different people types that we refer to here in this presentation. We refer to them as petties, or people types, or person types. We have created these types based on 4 variables which are like gender, age group, household type, and neighborhood type. We used K-means clustering for these last 2 variables. And then in the second step, we assigned another set of data that we have used. Actually, it's referred to CTS here, but it's COVID travel survey. COVID travel survey, which is a data gathering, which is a survey that we have done in 2020, 2021, and 2022 in 3 years, that captures different aspects of people's mobility and activities throughout the pandemic. And in the second step, we have assigned the typologies that we have already created based on OD data to the respondents of our opportunistic survey, CTS respondents, in fact, COVID travel survey respondents. And in the third step, we have designed a pseudo-panel approach. And actually, we have created cohorts of people, and then we have found the people types who are common, who are present in different years, in different surveys, to look how their travel behaviors, to observe how their travel behaviors have changed throughout the years, in the years. And also because in some of the cohorts there was not much observation, we decided to aggregate some of them using some of them who had similar frequencies of anticipated mode usage. I will explain all these in detail in the next slides. And then in the fourth step, we also have done we have found the associations, the associations between typology variables and anticipated mode usage frequencies. And at the in the last step, we have predicted the post-COVID mode usage of aggregated people types under different scenarios, under 3 scenarios, with marginal, moderate, and significant effect of COVID on travel behavior. And on the end, this will help us, and this will enable us to calculate trip rates and also mode usage of different groups of people for different horizons in the future. So first thing is to explain a little bit what was the COVID-19 travel survey. It's like a survey, as I said, that we have done in 3 waves, 2020, 2021, and 2022. It has different parts. The first part is on individual and household attributes. We have a section on home location attributes. Another part that we gather the travel behavior before and during the pandemic, and also a part that is related to this presentation, which focuses on gathering anticipated travel behavior of people after the COVID. And also there are questions about teleworking, online shopping, and other changes in the activity of people that are discussed in other parts of my project and not presented here. So for the anticipated travel behavior, we have asked people how would they travel they anticipate traveling in the future using three frequencies: less than before, same as before, and more than before. And we have asked them this question for different modes. The first one is for traveling in general, and then we have asked this question for walking frequency, cycling, public transportation usage, and car usage frequency. And then when we have gathered this data, the next step is to create the typology. So as I said, we have 4 variables. The first one is the gender. So we have 2 groups, men and women. Then we have 5 age groups. Then we have 8 groups that are like the result of K-means clustering of people based on 5 variables, which are household size, average age range, number of children less than 12 years old, and number of household members between 76 and 84 years old. And also the last typology variable, which is the neighborhood typology, also based on K-means clustering method. And there are 6 groups which are like calculated based on population, employment, and commercial density, total length of road network, density of intersections, and total transit stop times over 24 hours, number of bike sharing docks, and the last one, number of cars and car sharing stations. So using these, we have used these 4 variables to create our types, to create the typology. And for the household typology that I said, there were like 8 typologies that have been created based on the 5 variables that we have used. We have different types, so we have different household types. The first one is the multi-generational families. You can see them all here. I would just go through them very quickly. So we have very young families, traditional families, adults and seniors, young couples, roommates and singles, people in their 50s, and retired people. So each of these names came up from their the composition of these households. So for example, multi-generational families are those families that have people have members like a child, an adult, and like a senior, and the definitions match with the composition as we go on for the other groups as well. And also you can see here the distribution of these household typologies, both in OD data and in our COVID travel survey data. So the ones on the back, like the ones that are more that are darker, like the ones that belong to the OD survey, but the ones on top, a little bit light, are those from the COVID travel survey. So we can see that we have pretty much enough observation for each household typology, and it's a good representative of the population. And also for the neighborhood typology, we have 6 types, which are, I'm going to jump into the figure. So these typologies, starting from the first one, the first neighborhood typology, which describes the dense area of the central part of the Montreal, like the central business district. And then as we go forward with the neighborhood typologies from 1 to 6, it goes towards those areas that are less have less like options of public transportation and more rely on private cars, and like they're going towards the suburban areas of the greater Montreal area. So using all these variables and typologies, and also using the data from the COVID travel surveys at the individual level, we have created the cohorts. As I said, like our approach here is called the pseudo-panel, because the data that we have was not like a panel survey that observed people throughout the time, the same people throughout the time. We decided to come up with like a pseudo-panel approach to see the cohorts of people and their changes throughout the years. So we see the common attributes, and then at the end, we have frequency of travel and mode usage, which are the average values for each of these cohorts. And we use all these calculations to create the scenarios of the mode usage after the pandemic. So considering 2 genders, 5 age groups, 8 household types, and 6 neighborhood types, we have potentially there are 400 and 80 possible people types that can be made, but when we when we find the ones that have observations throughout the years in the COVID travel survey, we can see that out of these 480, there are 187 types that are that have observation in 2020 survey, 135 in 2025, 21, and 189 in 2022. And then when we keep those that are common, it gives us 116 types of people. But then, as I said, in some of these types, there are cohorts that do not have as much observation. So we have decided to aggregate some of them based on the similar observed frequency of anticipated frequency of traveling. So, for example, here you can see that for for it says the translation says shift, but it means travel. It's a translation from the French presentation. I'm sorry for that. But for example, for the traveling in general, we have observed that there's no difference in between men and women. So we could aggregate them, and this is also the case, for example, for people in age 15 to 25 and 65 and over. And we have done this aggregation for different modes and different groups and types of people, and this has led to, like you can see here, for example, 20 types for traveling in general, 15 types at the end for walking, 22 for biking, 30 for public transportation, and 16 for car usage. So this will enable us to create the scenarios, but before that, we have also done the we have found the association between variables and anticipated mode usage frequencies. We have used residuals of standardized chi-squared test here, and those greater than those with absolute values greater than 2.58. We have considered them a significant association. For example, you can see here that the age group of 65 and more are more probable to travel same as before the pandemic, use bike less than before the pandemic, and use public transportation in the same as before the pandemic. And also, we can see, for example, here for retired people, that they travel same as before, and also they use the public transportation same as before the pandemic. And like the blue squares here shows the ones that are like other significant associations between the variables and anticipated mode usage frequencies. And we also have calculated these associations after the aggregation, but I'm not showing them here. Just gonna jump to the scenarios themselves now. So we have three scenarios. The first one is marginal. So we have considered that those who said that we are gonna travel same as before, there will be no changes in their travel, in their mode usage. Those that said less or more, we will increase or decrease accordingly by 25%. Their traveling, their number of trips, and in the moderate scenario, it's the percentage of change is 50%, and in the significant, the percentage of change is 100%. So, considering these, we have calculated the the number of trips for total trips, in fact, using the anticipated mode usage frequency of people. So there are, on the left side of the figure, you can see here, we have the 2018 OD survey, which is like as a reference year. The number of trips there was like around 7 million trips. And then using the anticipated trip rates, travel frequencies, we have calculated the number of trips in the next year. So, for example, based on the 2020 COVID travel survey, 2021 and 2022, these are the estimates that are based on the anticipated travel frequency of people. And then we also have the forecast, which is like the projection of these 3 years for the next years, which are 2023, 2024, and 2025. So we can see here that for traveling, there was like a decrease at the beginning, and then we can see the mitigation of the effects and increase in the total numbers of trips in subsequent years. And the anticipations show that the travel, the number of total travels have returned back to its pre-COVID state in 2024. And then for walking, we have seen a significant increase at the beginning, and then it came back with a gradual decreasing trend to its pre-COVID state in 2025. And again, these are the values that have been like these are the anticipated travel behavior, travel frequency of people. And then for biking, we can see a significant increase again at the beginning, and then a decreasing effect in the next years. But here, the reason why we see a sharp decrease is because that the last survey, the last wave of the COVID travel survey that we have done in 2022 was pretty much in October, and like the anticipated travel behavior in the coming months was like somehow people anticipated their bike usage in the cold months of the year, so they anticipated lower values. So that's why the predictions here and the anticipations are plunging down and showing a sharp decrease. And then for public transportation, we can see a reduced usage of transit at the beginning, and then we can see a expectation of returning to its pre-COVID state in 2023. But when we compare here with the current statistics, with the real statistics, here you can see in with the red squares that there's a huge difference between what has people anticipated and what was the real values of transit ridership in Montreal. So we can see a huge difference in the 2020, 2021, and 2022, and also the fact that we did not consider the effect of teleworking in our prediction for public transportation was one of the reasons that there is a huge difference between the reality and the anticipations. So we have calculated this effect of working from home in 3 scenarios, like 1 day per week, 3 day per week, and 5 day per week. And we have used the percentage of work-related public transportation trips, as well as percentage of people who telework in Montreal. And we can see that the values, for example, 3-day scenario, if we consider that working from home 3 days per week, we can see that the return to normal, like the return to its pre-COVID state would be 2024. But the deviation between the anticipations and the reality can be due to several reasons. The difference between anticipated and adopted behaviors, people they didn't do exactly what they anticipated and what they said, and also the use of arbitrary values that we have chosen for scenarios for increasing and decreasing the number of trips of people, and also taking into account a constant percentage of work-related public transportation trips, because that comes from the OD survey in 2018, and also something around 5 to 6% population growth during this period in Montreal, and also based on the Quebec's interregional migration balance, like the report shows that there have been a spatial distribution of the population towards the suburban areas of the Greater Montreal area. So people have moved to these areas, and in the suburban areas, like the public transportation usage is also lower. So that's also aggravating the difference as well. So these were for the public transportation, and the last one is the scenarios for the car usage. They show pretty much they show a small reduction in the beginning, and then a relatively stable situation within the next years. And that's the last mode that we have. We have asked the frequency of frequency of traveling from people, and generally. Just to sum it up and to conclude the presentation, and also to explain on the usages of this approach. Well, we can use this approach to identify most important typologies for each mode according to their percentage of population, the percentage of population that they represent, or according to their percentage of trips. We can use a trip rate for different population segments. I haven't presented it here, but we can, and we have calculated the trip rate per each cohort of the population. And this approach also reduces the need to conduct OD surveys for certain population segments. And also there is a possibility of increasing precision and coverage with increasing sample size. Thank you for your attention and your time. If you have any questions, I would be happy.
Thank you. So maybe just Tom Hobalt's question is, why extend the anticipation of the next few months in 2023 beyond, sorry, in 2023 being extended over years into 2025? So I guess the question, given that it was 2023, why does the next few months include 2025?
Okay, so like we have 3 waves of survey, 2020, 2021, and 2022. And we each of them we ask them like how do you see that how do you think that you will travel in the near future? So we have decided to use these as a some kind of a trend for smaller cohorts, like for example, just reducing the scope and considering cohorts, and then just project it for the next years. It's true that the question was like for the near future, for the next, for example, couple of months, but we have decided to do this to see how would the anticipations of people work on the OD survey and on their number of trips, and see if it works like closely or there's a difference between them. So also there's another part of like my presentation that in addition to public transportation, it compares with car counters and also cycling counters towards in different areas throughout the Montreal. So I didn't present them here because I thought like I had 13 minutes something at the beginning. But for biking and car usage, the anticipations were pretty much close. And for not for all of them, but for like, for example, the majority of the counters. So yeah, the reason for like extending, we just wanted to explore what would be the result. But yes, that's completely true that it was like for the near future.
Great. So
And also we didn't like extend this until like 2015 or something like this. Even now we can see that we are
there's a few
past
other
that point. Yes, sorry. Okay.
there's a few other questions and comments in the chat box that I'll maybe let you address. Priyanka reminded me though that one of our speakers had requested to speak earlier than he was scheduled. So our next speaker will be Omid Armantelab, who is a PhD student, or I guess PhD candidate, I should say now, at the University of Nebraska-Lincoln. He was previously advised by me. We still work together quite a bit, but is now advised by Wissam Kantar. And so I'll hand it off to Omid whenever you're ready.
Thank you so much. Can you see my screen now?
Yeah, you just need to make it full screen. And then just switch to non-presenter view. So just go to, yeah, display setting. If you go to display setting, you can swap them. Yeah.
Okay.
Perfect. Go ahead.
Okay. Hello, everyone. This is Omid Armantalab. And as Dr. Hawkins mentioned, I'm a PhD student in transportation engineering at the University of Nebraska-Lincoln. Today, I present our work with Mohammed Alayan and Dr. Hawkins, which was about multi-stage clustering of daily human activities, patterns, and socio-demographic insights. So understanding human activity pattern is essential to many fields, from urban planning and transportation to healthcare and consumer behavior. These patterns help us to uncover how people move, interact with their environments, and make daily decisions. While a lot of research has focused on activity patterns over shorter time frames like single day or single week, in this study we are using a month data frame to kind of bridge the gap. And in this study, we are going to use a two-stage clustering framework that in which we apply dynamic time warping k-means in the first stage and Euclidean distance-based k-means in the second stage to have a comprehensive clusters of human activities. As I said, the data is over a month and is from 650,000 activities from 1,380 people. So the data we use in this study is a time use plus data set, which included the activities that I mentioned from 1,318 unique participants over a 28-day period that was collected in Switzerland in 2023. And the sample represents the German-speaking population in Switzerland, and it is weighted to be representative of these groups in Switzerland. In data processing, we had several steps that I'm going to just present one of them in this presentation. So the main data processing task was grouping activity, many activity types, as you can see in the second column. And we try to group them in 8 different categories. As you can see, we have a study, we have work, we have home, which includes cleaning, gardening, eating, cooking, home office, resting, sleeping, and nothing else. And transportation refers to drop-off, pickup, fueling, parking in a garage, parking outside, and waiting. And we have shopping errands category, which includes package pickup, drop-off, errands, shopping, online shopping, and we have also recreation and entertainment, which includes restaurant, hobby, leisure, digital entertainment, and so on. And we have also personal business and other. So with having these 8 activity groups, we are going to work on clustering them. So for our clustering task, we first produced or generated some time series of the activity durations. So we calculated the duration of each activity type for each day over 28 days period. For example, for shopping and errands, we have a time series, as you can see. It is SI1, SI2, SI3. Each of them represent the duration spent on that activity on that day. For example, SI1 is the duration of shopping in day 1 for individual I, and so on for other days. And we said that in the second stage of our clustering, we use Euclidean distance. So we first introduced the Euclidean distance. So Euclidean distance is a straightforward metric that can be used as a similarity measure or distance measure between 2 time series. That it works by calculating the point-wise differences in values between corresponding observations. So if we have 2 time series, the Euclidean distance exactly calculates the difference between day 1 of both, and then the difference between day 2 and day 2. So all of them are fixed in time. And as we mentioned, we use dynamic time warping as similarity or distance measure in the first stage of our clustering instead of Euclidean distance. And dynamic time warping allows for nonlinear alignments in time axis that can be used as a similarity or distance measure and is irrespective of their exact alignment in time. So they don't need to be exactly, for example, day one and day one. So if, for example, if we have, for example, two time series that have a peak, but the single peak in the first time series is in the middle, and in the second time series, the peak has a shift, for example, and this dynamic time warping method can account for that shift. So why dynamic time warping is suitable for our clustering tasks? As we discussed, it is suitable because it allows for temporal shifts. And for example, in human activity data, we can have two individuals that have similar shopping patterns. For example, both of them do shopping once a month, but one of them does shopping in the middle of the month and the other person does the shopping in the first of the month. Although both of them are shopping once a month, but if we use Euclidean distance, we are not accounting for this shift. But with dynamic time warping, it can handle temporal shifts, and so we can conclude that these two persons have a similar shopping behavior. So let's take a look at our two-stage clustering task. So we started with survey data. We created the time series for each activity and for each person. Then in the first stage, we do dynamic time warping based k-means clustering for each activity type. And then we analyze socio-demographic variables for each activity. We use chi-square test. And in the second stage, we actually use the first stage clustering results to perform Euclidean distance-based k-means or the conventional k-means clustering to obtain final clusters or comprehensive clusters that in this study we conclude we have 6 comprehensive clusters, and also we do the chi-square test finally. So let's see the results of this study. First, we present our result, the first stage, which was the analysis of individual activity categories. So in this presentation, I'm going to present the results for only shopping and recreation. And because I think we don't have time to discuss the other 6 activity types. So we'll first start with shopping and errands. So the Silhouette score plot can be seen here, and we can see that it shows the Silhouette score for dynamic time warping in blue and for Euclidean distance in red. So we can see that when we use the dynamic time warping, we have a much larger Silhouette score, which means better clustering. And also based on the dynamic time warping that we are using in the first stage, 2 clusters is the optimal number of clusters to cluster the shopping and errands. So by using the k equals to 2 in our dynamic warping k-means clustering, we are going to see the results of these 2 clusters. In first cluster, we see it's 47.8% of people are in the first clusters, which, as we can see, they seem to do shopping once a week, probably at weekends. And the second cluster, which is 52.2% of people, so they spend the majority of their shopping time on a single day, although they might go to shopping on other weeks, but the majority of shopping is concentrated on a single day. And by analyzing these socio-demographic variables, we can see we have the analysis for gender, age group, education, household income, marital status, household size, and different variables. Here we are going to just focus on some key results. So the results for shopping and errands show that women are more inclined to shop on a weekly basis, whereas men are more likely to shop on a monthly basis or concentrate on a single day in a month. And married individuals indicate a preference for weekly shopping, whereas unmarried individuals do shopping on a single day. And having young children in the family is related to weekly shopping. Let's go to the second activity type. So for recreation and entertainment, again, we can see that the dynamic time warping is producing a larger silhouette score, which means better clusterings than the Euclidean distance. And considering this dynamic time warping, we can see that the highest score is for k equals to 2. So we conclude that the 2 clusters is the optimal number of clusters for recreation and entertainment. By using k equals to 2, we can see the 2 clusters of recreation. The first cluster is 48.1% of people. So they spend time on recreation almost every week. But the second cluster, we can see that it's kind of centered on 1 week and zero recreation in the rest of the month. And by analyzing the socio-demographic variables, so some of the key results are as follows: that women engage in recreation more frequently than men within a month, and individuals with higher education tend to participate more frequently in recreation, and also having young children limits opportunities and for recreation activities. And for the other clusters, we are not going to discuss them in detail. We can see that for home, again, we see that dynamic time warping is producing better clusters. And also we see the 2 clusters for home. For work, we see the better performance of dynamic time warping and 2 activity patterns for work. And for transportation, the same results, better clusters for dynamic time warping and the 2 patterns. But for study, we can see that so again, we have a better results for dynamic time warping, but the optimal number of clusters is around 8. So we can see that for clustering study, we need more clusters compared to the 5 activity types, which were kind of mandatory, but for a study, we can see people have more different patterns. And for personal business, we can see again, dynamic time warp has a better performance, and also we need about 8 clusters for personal business as well. And for other activities, again, better performance of dynamic time warping, and also we need 8 clusters. And in the second stage of our clustering task, we said we used the results of the first stage clustering task to do Euclidean distance or conventional k-means clustering. And the silhouette score shows that about 6 clusters is the optimal number of clusters for our second stage clustering task. And by using k equals to 6 and performing the k-means clustering, we can see the, on this figure, we have 6 different comprehensive clusters. And on the x-axis, we have the first stage clusters. For example, first cluster of shopping, second cluster of shop, recreation cluster 1, recreation cluster 2, and all of the clusters of the first stage clustering. And in this parallel coordinate plot, we can see the percentage of each of these clusters in the 6 comprehensive clusters. And some of the key results show that, for example, comprehensive cluster 6, this one is showing that that cluster tend to spend more time on personal business and other activities, while less time on study and work, and spend more time at home and in transportation and shop and engage in recreation more frequently. And also the socio-demographic analysis, which is not presented in here, show that these clusters that has this pattern are more older people, unemployed, women often living in non-traditional housing and spending less time online. Said that in this study, we analyzed human activity patterns across 8 primary activity types that was coded over months. And in the first stage, we used dynamic time warping based k-means clustering instead of Euclidean distance. And we saw that the dynamic time warping accounts for temporal shifts or misalignments, and compared to Euclidean distance-based clustering, is producing more cohesive and meaningful clusters, and also higher silhouette score across all activity types. And we saw that we have high variability of clusters in study, personal business, and other activities, which required up to 8 clusters, while more consistent patterns we had in shopping, recreation, home, work, and transportation, that we did clustering by only 2 clusters. And the socio-demographic analysis, so one of the key results was that it showed that younger unmarried individuals without children tended to engage more in study activities, while unemployed individuals were more active in personal business and recreation. Thank you.
Thanks. Thanks, Omid. Any questions for Omid?
You know, something I was hoping to get a sense of when I joined this session is how different countries compare. I don't know if Omid or others have answers to that kind of question, but I'd feel free to put them in the chat box because everybody else is muted except for the co-hosts. But Omid, if you have a thought on how different nations vary, you know, with real numbers, that would be fantastic.
Oh, so excuse me, I didn't get the question. You are asking that
I think the question is, how do travel patterns vary across different countries?
oh, okay, yeah.
And Omid actually Omid did a survey in the US Midwest and has done a bit of work with US data. Like you've seen here, he's working on Austrian data, and then he has some other current work that's using Japanese trajectory data. So he has been studying a few different places. I don't know if you have thoughts on it, Omid.
Yeah, I think it's Might be, yeah, I can say, but as
Yeah.
as we mentioned in this study, the sample was from German-speaking people in Switzerland. That it is one of the limitations of our study, that it can be different for other nations or even different groups of people in Switzerland. Maybe we have similar patterns for main activities, but for personal business study or these patterns. So yeah, that would be interesting to have another data set and compare those patterns to see how they differ.
Well, if there aren't any other questions for Omid, maybe we can go to the next presenter who I know is in the room. Paulina Polakina, and I'm again sorry if I've mispronounced your last name, is a master's student in transportation engineering at the University of British Columbia. And prior to going back to school for her graduate degree, she was a consultant in Portland, Oregon, where she primarily worked on active transportation projects, and that's what her master's is focused on, is electric bicycle adoption.
Great. Thank you, Jason, for introduction. Can you guys hear me well?
Yep.
Okay, all right, I believe I have shared my screen.
Yeah, I can see it.
Okay, great. Thank you. So welcome to my presentation. I'm going to talk to you about how we can power large-scale e-bike adoption, where I am investigating the impacts of the British Columbia-wide e-bicycle rebate program. Sorry. Oh, okay, there we go. So very quickly, I want to talk to you about like what are e-bikes and why. And an important distinction in our context is that e-bicycles, they're electric assisted bicycles. So they're bicycles that have pedals, but they also have a motor that allows you to make your riding a little bit easier, which is very different from context of other countries where oftentimes e-bicycles are called what we refer to as e-scooter. Electric mopeds. So this is not what I'm talking about in this presentation. And the reason why there is so much interest around the world for e-bikes is because they can provide better mobility options than conventional bicycles because they're easier to ride and they can allow people to go further distances. And previous studies have shown that e-bikes can sometimes effectively replace travel by cars, which is why many jurisdictions around the world are interested in increasing e-bike adoption. So which is with the interest of uptaking e-bike adoption, different governments employ these programs where they provide rebates or a monetary subsidy for purchasing an e-bicycle. And so in this presentation, I'm talking about the program that took place in British Columbia, which is located in Southwest Canada. And the goal of these British Columbia programs were to support active transportation, make it more affordable, specifically to people of lower incomes, and contribute to the province's greenhouse gas emission reduction goals. And they embarked on this research. There was very little quantitative information and data available about how these rebate programs affect travel behavior and what the benefits are. So we aimed to quantify the net travel and other related impacts that can be attributed to this rebate program. So here is a quick overview. This rebate program, the rebates were distributed between the summer of 2023 and 2024. They went out to people all over British Columbia, both in in urban and rural areas. The rebates were available in 3 tiers, $350, $1,000, $1,400 rebates. And those larger rebate amounts were only available to people from lower incomes. So they were income thresholds for how much money you needed to make to qualify for these rebates. And for reference, these are Canadian dollars, and each Canadian dollar is approximately equal 70 US cents. So when converting to USD, these rebates equate to like slightly smaller dollar amount. And the province had distributed approximately 5,000 rebates all over the province. To study this program, we employed an online survey of 3 waves. With the first survey that people completed at the time when they purchased the bicycle, then another survey 3 months later, and another survey 12 months later. For reference, we started out with about a sample of 1,000 people and ended with a sample size of around 450 people. This is a ginormous survey that people took, and there is a lot of interesting results and insights that we found, but I'm going to try to keep this presentation somewhat brief. So first off, we know that people receive rebates, and then we know that they buy e-bicycles, but how does that compare the amount of rebate to this bicycle cost? So we can see, so the blue bars represent the amount paid by each participant, and the orange represents the incentive amount. And we can see that obviously with the small rebate amount of $350, that only covers about 10% of an e-bike, so it's not a substantial subsidy. But with those larger rebate tiers that went to people from lower income, those rebates covered almost half of the purchase cost, therefore providing quite a large financial subsidy to people. And as we can see, the average e-bike price is around $3,200, which is substantially more than a conventional bicycle. So these rebates really provide some good financial benefit. But it's also very important to understand how effective these rebates are in generating new purchases. So we asked people in our survey, what would you have done if you did not receive this rebate? And we gave them 4 different options, out of which we are mostly interested in understanding these people who reported they would have bought no bicycle at all, or they would have bought a conventional bicycle, which means in those instances, people would have bought no e-bike at all. And this is very important to understand because this concept allows to quantify the cost effectiveness of these rebates. Because if, let's say, the province gave people money, but all these people were going to purchase bicycles anyways, that means that the program is wasting money. But we find that this cost effectiveness is on average around 60%. So 60% of each rebate dollar that the government spends goes towards actually generating new e-bike purchases that would not happen without rebates. So here is a quick overview of people experience and considerations in using their bicycle. On the right side, on the graph on the right side, we can see that on average, when compared to reality of e-bike ownership to expectations, people report that across most factors, their experience is significantly better. They leave us a lot of comments about how they did not expect that e-biking is going to be so much fun, that they're riding it is a lot more frequently than they expected, and they just overall feel much happier and healthier in life because now they're able to exercise while like traveling on their daily basis. It's asked about their considerations in using the bike compared to other modes. Weather comes up a lot, as well as physical effort, but also this concept of fun turns out to be very important to people. When we embarked on this study, we did not think that this program will bring people joy and fun, but this is a very important factor that we found to be underlying throughout the use of this e-bicycle. So it truly brings people a lot of joy to be riding e-bikes. So we also ask people about how they use their e-bicycles. So this is on the x-axis in the y-axis, we have trip purpose. And then the x-axis, we have other modes that people would have used instead of the e-bicycle. And we can see that while exercise and leisure trips are the most common one at about 30%, still, the majority of trips that people are doing with these e-bikes, they are utilitarian trips. Yes, and when we think about alternative modes that people would have used in the absence of this e-bike, the most common mode that people are replacing is automobile, which involves both like single occupancy driving and carpooling, and it's around 40%, which is quite substantial and consistent with other studies. We also find that about 16% of trips that people make are new trips. So that means that these e-bikes are providing people this new mobility that they would not have had otherwise if they had not purchased this e-bicycle. And we also ask people about their overall travel behavior before purchase and then after purchasing the e-bicycle. And what we see is that after purchasing the e-bike, they substantially increase the e-bike use, but they also reduce their driving and automobile usage by quite a bit. So if before e-bike purchase, most of people's travel, almost 60%, was completing by an automobile. After purchase, that number goes down to 44%, and 30% of the travel is completed by e-biking. We also see a reduction in conventional cycling and in walking and in transit, but this also varies substantially depending on where people live. So in areas where transit is more common and people did ride transit more frequently pre-purchase, those are the places where they reduce the transit use the most. We also studied a lot of different factors that influence these changes, and I'm not going to talk to you about all of them, but just kind of wanted to highlight a few. That, for example, household income is something that comes up strongly across all of our findings, and we see that if people who have higher income, they are less likely to be motivated by this rebate to make a new bike purchase. So they're more likely to buy the e-bike without the rebate. They're also, people of higher incomes, less likely to do new additional e-biking, but at the same time, they're more likely to replace auto travel with the purchased e-bicycle. People who are commuting, they come up positive across all fronts, so they are very motivated by these rebates. They usually do a lot more new e-biking, and they're also replace auto travel. We considered a variety of geospatial factors, and we also find that people who live in places with warmer winter temperatures, so milder climates, so so more like southern BC, they are also more motivated by their rebates, they do more new e-biking, and they are more likely to replace auto travel. In summary, there's a lot of different benefits, positive benefits that we found that can be attributed to this program, both for the society in general and the province, as well for the people themselves. So first up, we find that the program generated new e-bike purchases that would not have happened otherwise in the absence of these rebates. We find that the program effectively reduced the purchase cost of each e-bicycle and made people daily transportation cheaper by approximately 12%, because it primarily comes from the fact that people are reducing driving, which is substantially more expensive than e-bike usage. E-biking brought people a lot of joy, improved their mental health and physical health. And when quantified, we find that despite decrease in walking and conventional cycling, because people are still doing longer trips and they're traveling more by e-bike compared to like transit or auto travel, their overall physical activity that is related to travel increased by 13%. On a typical week, people e-bike approximately 50 kilometers, and 70% of those trips are utilitarian. With 16% of the trips is new access to new destinations that people didn't have before. And because such a large percentage of e-biking replaces auto travel, it leads to a net reduction in greenhouse gas emissions. I'm going to conclude here. I want to thank my advisor, Dr. Bigazzi, and other co-authors in the study. Please check out the work of our lab at reactlab.civil.ubc.ca. And now I'll take some questions if you have any.
Yeah, so there's a few questions in the chat. I guess the first question from Michael Highland is, do you know what bikes each participant purchased and the price paid? And I can see Alex responded, it's a bit messy. You have make and model, but do you maybe want to comment a little bit more on that?
Yeah, so we do have a make and model. We did find that it can be tricky to pinpoint the specific bike because there's such a wide range of models and you'll change one letter in the model name when it's a completely different bicycle. And we find that on average, people pay, like the total cost of an e-bike was around $3,200 and 3,200 Canadian dollars. And people paid themselves out of pocket about like 1,900 Canadian dollars.
Great. So maybe I'll take a question from Alex Bettinardi. Any information on older travelers making the choice to use e-bikes compared with non-electric bikes? Are they more likely to use them?
Yes, I would say that we probably found that I can't tell you exactly if older folks were more likely. They actually think, if I'm not mistaken, they were more likely to use e-bikes, like other e-bikes pre-purchase. Can't tell exactly if they were more likely or less likely to use conventional bicycles pre-purchase. But overall, I'm looking at our data here, is that the people of older age, they were more likely to increase e-biking, so do more new e-biking, and they were also more likely to replace auto travel.
Sure. So then maybe one more question or comment for you to maybe provide some reflection on. Cara Kockelman sort of gives sort of some of her experience, I think, biking in Austin, Texas. So I think, do you have any comments, I guess, on sort of the safety factors around biking in general and then I guess e-biking specifically?
Yes, I would say that definitely, you know, like so safety, which in this graphic refers to like parking safety, is something that people express a lot of concerns about. People do comment quite a bit on the e-biking infrastructure. What is interestingly is that we did not find a relationship that in places with better biking infrastructure, people don't necessarily do more new e-biking, so we did not find a strong relationship there. People we asked people about whether they've, you know, got into a crash, whether it's with an object or a car or another person. And it's not like we don't see like really high amount of crashes. We don't see a lot of I think there was only 1 or 2 crashes that resulted in a hospital visit. It lists, like from a year of 500 people e-biking. So the experience can vary substantially, depends on where you live. If you like in a more urban area, like in Vancouver, or in a more rural place where you don't have any infrastructure. So short answer is that it's a very complicated topic, and I don't have a easy answer.
Sure. Great. Well, thank you very much for the presentation. I think we'll maybe next go to Hannah Hook's recorded presentation. And while Priyanka is bringing that up, I'll just say it's unfortunate that no one's here with me in Calgary. I'd put the effort in this year to get some snacks and things and book a meeting room, and it's just me. So if anyone wants some snacks, I can ship them in the mail. So is the presentation ready, Priyanka?
Can you see my screen?
Yep. Yeah. So
Okay.
I'll just quickly say, so our next presenter is Hannah Hook, who's a human geographer with research and teaching experience in Belgium, the UK, and the US, and is an alum of the EIT Urban Mobility Doctoral Training Network. She is currently a postdoctoral researcher at Ghent University, but I'd say the reason for her absence today is she is on her way to travel to start a tenure track assistant professorship at Aalto University in Finland. So congratulations to her. Sorry she can't be here in person, but we'll look forward to her presentation.
Hello, my name is Hannah Hook. I'm a postdoctoral researcher at Ghent University, and I'm here to talk about some research that I did, a review paper that I did regarding the impact of discretionary trips on well-being. So this work explores the underappreciated role of non-obligatory travel in shaping well-being. So traditionally, we've seen travel like as a means to an end, just from getting from point A to point B as quickly and efficiently as possible. But discretionary trips, or trips that are taken for leisure, for social reasons, or for enjoyment, can also provide benefits like physical activity or emotional benefits or social benefits that those maybe more routine trips like the commute won't. So we have often looked at travel as a derived demand, but I would like to frame it instead in this presentation as a positive utility. So maybe not looking necessarily at the commute, but looking more at going on a bicycle ride for fun or walking to a friend's house. These trips have benefits for objective and subjective well-being potentially. Just for a couple of examples here, there are different trip circumstance examples. So a very, very necessary trip on the one end would be clocking in for work. You must be there at a specific time. You don't have any flexibility. But on the other hand, going for a walk is completely discretionary. You have no obligation to do it. You're able to choose it for yourself. So within these spectrum of trips, this obligatory or necessary to discretionary spectrum, there might be different well-being benefits that we gain from these different types of trips. And maybe with these more discretionary trips, there's a greater chance of improving our well-being with these trips because of their lack of obligation or necessity. So why might directed travel be particularly important to well-being? First of all, we have health-promoting behaviors. So more leisure-oriented travel is more likely to be taken with active modes such as walking or cycling, and that can contribute to physical fitness, whereas these other necessary trips might not be as taken with active modes, so they might not give these kind of really physical health promotion behaviors. Secondly, there are psychological benefits, so emotional benefits and psychological benefits. Discretionary trips are going to, by nature, be more enjoyable, potentially more relaxing, more mentally restorative, and they might even involve nature or enriching destinations, so this can help to reduce stress and improve mood, whereas those other trips might not. Third, we have autonomy and choice. So because, like I said, discretionary trips are taken entirely voluntarily, they let individuals feel a sense of control over when, where, how they travel, which can be linked to satisfaction with life and self-efficacy. And finally, these more discretionary trips might be undertaken for socialization reasons. So not only traveling with a companion, but also just viewing people on the street, spending time outside, which can improve feelings of belonging. It might reduce loneliness, and it could in turn improve well-being. Another reason why we might care about looking at discretionary travel as opposed to more necessary travel is because we're in a time of different types of transitions. First, there are digital transitions, such as teleworking and online shopping. So maybe because of the rise of these activities online, we aren't taking as many necessary trips, meaning that our overall discretionary travel percentage rises potentially. Next, we have climate transitions like decarbonization and pollution reduction, which means that we're trying to overall travel less. And there are also social transitions such as the aging population and evolving gender roles, which all have the potential to greatly influence our daily travel patterns. So these shifts are redefining how, why, and where we travel and who gets to travel in different ways. And this could potentially, like I said, decrease necessary trips for some, and make the discretionary travel that they take overall more important to how travel affects their overall well-being. So, like I said, this was a review paper.
I've got so many questions to respond.
The words that I used to search for different types of papers. This was done through Web of Knowledge, Scopus, and then Google Scholar as well. So the different words that I used for discretionary were optional, voluntary, non-mandatory, non-compulsory, unrestricted, elective, undirected, or leisure. And then I looked for, on top of, in addition to that, trip, travel, transport, or mobility. I looked for well-being and happiness as well. And then I made sure to not include anything regarding tourism or vacation or holiday, because that often could get roped into these kind of leisure trips, and that's not what I wanted to do. I only wanted to look specifically at daily travel. So in terms of the records that were screened, Web of Science gave 229, Scopus gave 298, so I had a total of 527 records, and then I removed 175, which were duplicates. Of those 352 that were left, I screened titles and abstracts and ended up excluding 275, which left me with 77 articles to read in full, of which I then excluded 16, leaving me with a total of 61 articles that are included in this analysis. You can just see here a quick map of where the articles come from. Most of them, understandably, are coming from Europe. There's quite a few coming from North America as well. Asia and Latin America are also represented, with Africa being the only continent that isn't represented, and Australia also had a few articles coming. In terms of the field of research, so the journals that they were in, the overwhelming majority were in transportation and travel behavioral journals, but there were also quite a few in health, medicine, and psychology. Fewer in environment and sustainability, some in leisure and culture, urban studies, and spatial planning, and then just 2 as well in aging and gerontology, in the field of aging and gerontology. In terms of the populations that the different articles were sampling, again, the overwhelming majority was just a general adult sample, so 41 of the articles. There were also 10 that looked at older adults, 2 that looked specifically at children, 2 that looked specifically at participants with disabilities, 4 that looked specifically at young adults, and then quite specifically, 2 that looked at young adults with chronic or genetic diseases. In terms of the methods that were used across these different articles, it was very different. So there were factor analyses that were used, different types of qualitative analyses, different types of quantitative analyses, and quite often structural equation modeling was also used. So overall, I found 8 themes, and they fall into 3 different categories. And this emerged from a thematic synthesis that I did, looking into all these different objective and subjective measures of how discretionary trips enhance well-being. So the first theme, and these first three were these kind of major contributing themes. The first one being understandably physical health. So this was the one that was most robustly supported by empirical evidence. This included health benefits, well-being benefits such as cardiopulmonary function. It included healthy body weight, physical activity, physical limitations, muscle use, slowing down aging, fatigue, sleep duration, these types of things. So really, really only considering physical activity, physical health. The second major contributor was social connections and belonging. So this included themes like maintaining networks, reducing loneliness, fostering community, and this was particularly important for vulnerable groups. The third major contributor in terms of the relationship between discretionary travel and well-being was autonomy and freedom. So these themes surrounded self-efficacy, personal control, in the elderly populations, driving cessation, feelings of escape, feelings of resistance, feelings of freedom and independence, being able to make voluntary movements. This was this third major contributing theme. The next two themes were more context-dependent influences. So these were more like broad external conditions that shape the extent to which the discretionary travel impacts well-being. So the first theme within these context-dependent influences were mental health. So this was more variable than, for example, physical health. So this included themes such as depressive symptoms, de-stress, loneliness, isolation, relief from confinement, removing negative feelings. So these are more, context dependent and maybe not necessarily happening all the time for every trip. The other context-dependent influence was environmental and urban design. So this is more concerning the way that access to discretionary travel is shaped and opportunities for discretionary travel is shaped. These themes included accessibility, for example, development, density, the 5Ds, pedestrian spaces, open spaces, entertainment, aesthetics, parks, crime rates, calm spaces, weather. So all of these were different depending on different types of trips and different types of destinations, and maybe weren't apparent for each and every trip. Finally, the third overall contributing theme that I found was situational and momentary influences. So these are more trip-specific factors that affect the immediate experience. So not these more contextual, like environmental factors, and not these major contributors, but really about this one trip, this one time. First of all, the first theme is emotions and experiences. So this is really whether or not the participants were feeling enjoyment or joy, what their attitudes were during this trip, whether or not they were satisfied, if it was habit, if it was linked to tradition, these types of themes. The second influence was trip characteristics and circumstance. So this is really to do with, like, for example, which mode they were using, where they were going, whether or not they had a car ownership, if they were using active modes, if they could afford it, if it was flexible, the day of the week, household structure, driving licenses, this type of thing. So really about one trip during that exact moment. And then for the third theme that I found was psychological state development and feelings of achievement. So this is really more difficult to measure, and it, I think, had a lot more to do with individual predispositions and life circumstances, but these were still contributing factors to the relationship between discretionary travel and well-being. So this is whether or not there were feelings of achievement, whether or not the trip maybe provided personal growth, and this was more evident in the populations with disabilities, whether or not it was a challenge, whether or not it offered exploration, what the values that it contributed to, what the trips contributed to, whether or not it allowed for mind wandering, which preferences, whether or not, they were restorative experiences, and these were really, during this one trip, and really for particular different types of people. So maybe certainly less of an impact than, for example, physical health. So these 8 themes emerged from this thematic synthesis, and these themes form the conceptual bias for understanding in general how discretionary trips enhance well-being. or impact well-being, both objectively and subjectively. So what does this mean? What can we do with this? In terms of policy, there's a couple of implications that I outlined here. So we can invest in active, safe, and aesthetic environments. So creating walkable or bikeable environments could increase participation in discretionary travel, and it could reduce barriers for vulnerable groups. Second, we need to enable participation by addressing affordability, accessibility, and safety barriers so that people can have more and better discretionary trips for everyone. And finally, we should be encouraging flexible working and local accessibility. So with flexibility and accessibility, the options for discretionary travel could improve, and this could improve at different moments, at different places for different people. In terms of future research, I have a couple of different routes, because of course this was just a review paper, so this needs to be investigated empirically. First of all, causal links should be investigated to look at the relationships to both objective and subjective well-being for each of these different themes. Second of all, looking at the long term, so how does discretionary travel affect well-being over time? Looking at equity and intersections, so who is reaping more benefits from discretionary travel, who's able to travel more comfortably, who has more time for discretionary travel, these type of questions. And then finally, looking at emerging technology, how do e-bikes, for example, or mobility as a service or other emerging tech, as well as how do technical transitions such as teleworking affect discretionary travel behavior, and what does the future look like in terms of these new technologies for taking more trips that are optional? So in general, overall, I would like to argue that discretionary travel is often devalued in transport planning compared to necessary trips, where we only focus on the commute and we only focus on getting from point A to point B. So we should start to consider it as equally important, particularly because we know that it contributes specifically to social opportunities, to physical health, and to autonomy. So planning should move beyond necessity, and we need to look to build cities for more meaningful movement, in addition to getting from point A to point B and a derived demand. Recently, this paper was published in Transport Reviews, so you can check it out there if you'd like to read it, or send me an email. And finally, thank you for your time. I'm Hannah Hook again, postdoctoral researcher at Ghent University, and happy to be here presenting. Thank you.
Well, I don't know that we have someone to answer the questions. If you have questions for Hannah, so maybe we just move on to the next speaker. And if you have questions, I'm sure you can send those by email. So our last speaker, who was also our first speaker, Rizwana Rafiq. Priyanka, do we have the recording ready? It looks like yes.
We do have.
Great. And for this one, we do have
Welcome
some
to the presentation. I'm Rizwana Rafiq from University of California, Irvine. We, the UCI team, will present our paper today on the impacts of working from home on VMT through the mediating roles of travel efficiency and non-work travel. As we all know, due to the COVID-19 pandemic and its subsequent travel restriction policies, working from home arrangements significantly increased during 2020 compared to prior years. A survey conducted in 2020 pandemic year estimated that between February and May 2020, over 1/3 of the American labor force replaced in-person work with working from home. This percentage is about 6 times higher than the pre-pandemic level. If we look into the recent data set according to the 2022 National Household Travel Survey data, the full-time workers aged 16 years or above are distributed in this way. For example, 56% workers reported in-person work only, 23% reported doing work both at home and commuting to workplace. Among them, 15% worked at home 1 or 2 days, and 8% reported work from home 3 to 4 days. And finally, 21% reported work from home only. Such changes in work arrangements change the travel behavior. For example, telecommuting eliminates commute trips, but the time and money saved in foregoing trips might result in more non-work trips and more distance traveled. However, Obaid and their team conducted a research in 2024 and found that although one additional non-work trip was generated when workers telecommuted, but the total distance traveled on telecommuting days still remained lower than the commuting days. Wang and Mokhtarian in 2024 found a significant reduction in VMT by telecommuters, particularly those who telecommuted at least three times a week. Zheng and their team also observed a significant decline in transit ridership, carbon dioxide emission, and VMT due to the reduction in commuters. So on one hand, some studies found that working from home might generate more non-work trips. On the other hand, several studies found that it contributes to more efficient travel by reducing single occupancy vehicle trips and increased use of active travel modes. Telecommuters, so it is also found that telecommuters also form complex trip chains and carry out more short trips near their home location. So it is there essential to understand the intricate relationships between work from home and travel from multiple perspectives, such as efficient travel choices, non-work travel demand, and VMT. In this study, we primarily investigate relationships between work from home and VMT through mediating roles of non-work trips and travel efficiency. According to the Environment Protection Agency 2021, travel efficiency strategies include various strategies to reduce travel, particularly single occupancy vehicle travel, to reduce pollutants and greenhouse gas emission. In this study, we define travel efficiency as a theoretical concept that measures the potential impacts of travel on the transportation system and the environment. So here, more efficient travel incorporates non-motorized trips, transit trips, short distance trips, and activity travel chaining. On the other hand, less efficient travel involves long distance unchained single occupancy vehicle travel trips. So the goal of our study is to understand the post-pandemic impacts of work from home on travel behavior using large-scale national level household travel diary data. In this context, the study aims to address three questions. Is work from home associated with greater travel efficiency? Does work from home result in more non-work trips? And does work from home increase or decrease VMT? For this study, we used the 2022 National Household Travel Survey data. The data was collected from January 2022 to January 2023. The dataset comprises 4 data files. That means it provides information and data on households, person, trip, and vehicles. It contains data on around 31,000 trips, 10,500 persons, and 6,000 households. The study group consists of full-time workers aged 16 or older, working a minimum of 30 hours per week. That means we only included the workers who are full-time workers and who are aged 16 or older. So this is the data filtering process. We took the full data set first and then removed the non-workers, since we are only including the workers in our study. And we removed the part-time workers since we are interested in only the full-time workers. We defined the part-time workers as the workers who worked or reported their work hour less than 30 hours per week. We then removed workers who drive for work, and the filtered dataset contains data of workers on 3,794. These are the summary statistics. In this graph, we are showing the distribution of the frequency of non-work trips by different worker groups. Here on x-axis, we have shown different worker groups. For example, 0 days of working refers to in-person work only. 1 to 2 days and 3 to 4 days indicate hybrid workers. And 5 or more work from home days refer to work from home only workers. Compared to the worker group who never works from home, the leftmost column, the group that only works from home, the rightmost column, contains 39 percentage points more workers making at least one non-work trip on the travel diary day. We can see a very little blue color portion on these 5 or more column compared to the leftmost column, like the 0 days column. Again, the blue color actually shows the no non-work trips, that means 0 non-work trips. 1 to 2 non-work trips are represented by orange color, and more than 3 non-work trips are represented by the gray color portion. This graph shows the distribution of car and non-car travel distance by different worker groups. It shows that workers had a higher proportion of total travel distance in non-car modes when their work from home days increased. The rightmost column has a greater proportion of non-car travel distance compared to the leftmost column, like the 0 days work from home column. Let's discuss the modeling framework. In this study, we conceptualized interrelationships between work from home, travel efficiency, non-work travel, VMT, socio-demographic, and location characteristics by using a structural equation model. Structural equation model is a regression-based statistical modeling framework that can simultaneously estimate the statistical relationships among a set of observed and unobserved variables based on a specified conceptual model. Here are the steps. Here are the steps. We can see that we have first developed the conceptual structure, then identified the exogenous and endogenous variables for the model, then estimated the model by using the maximum likelihood estimation technique, and evaluate the model by using the model fit statistics, and then based on the final model that we have chosen, we interpret the results. So this is our conceptual model. Here the rectangular boxes in the figure denote observed variables. The oval shaped boxes represent the latent variable, and arrows indicate hypothesized non-zero direct effects. We captured the effects of work from home on VMT both direct and indirectly. So one indirect connection is through travel efficiency, and another indirect effect of work from home on VMT is provided through non-work trips. Travel efficiency is expressed as a latent factor in the study, characterized by 4 measurement variables such as activity travel ratio, proportion of short distance trips, proportion of micromobility trips, and proportion of travel time in transit and micromobility. Socio-demographic and location characteristics are hypothesized as exogenous variables influencing work from home, travel efficiency, non-work trip rates, and VMT. This slide is providing the detailed conceptual model, including all the variables that we used for the model. So under socio-demographic characteristics, we considered household income, household size, number of household vehicles, number of household workers, workers' race, age, gender, educational qualification, hours of work in a week. And as location characteristics, we use the urban area size where the worker lives and the availability of public transit. So this study estimated the relationships in the conceptual framework using the structural regression model, which is the most generic form of the structural equation model. The structural regression model comprises two parts, a measurement model and a structural model. The measurement model includes the latent variable and its relationship with the indicators, and the structural model includes the relationships between observed variables and between the observed and latent variables. Here are the model estimation and fit statistics. We estimated the structural regression model using the maximum likelihood estimation technique. And here you can see the model fit indices. And based on the model fit indices, we can conclude that our postulated model of causal structure fits reasonably well with the data. And here are the results. Here we can see that the estimated standardized factor loadings from the measurement models. And among the four indicators, the proportion of micromobility trips and travel time in non-automotive modes appear to be stronger travel efficiency measures with the standardized coefficients of 0.89 and 0.96 respectively. From the structural model, the estimated direct effects between the four endogenous variables are presented in this diagram. Confirming our hypothesis, we see that work from home has a negative direct effect on VMT, and the effect is minus 0.0029. Work from home increases travel efficiency, which in turn reduces VMT. On the other hand, work from home increases non-work trips, which in turn increases VMT. So we can say that work from home has a negative indirect effect on VMT through travel efficiency, but a positive indirect effect through non-work trips. Combining the direct and indirect effect of work from home on VMT, we obtained a negative total effect of minus 0.0026. Therefore, there is a net negative effect of work from home on VMT even after incorporating the positive effects. Considering a log linear equation for VMT, we can say that 20% increase in work from home days or changing one weekday commute to work from home would result in a 5% decrease in VMT per day. Here are the major findings. From the interrelationships between work from home, travel efficiency, non-work trips, and VMT, we can conclude that the more the workers did work from home, the more efficiently they traveled. It implies that a higher frequency of work from home is associated with performing more activities per trip, making more short distance trips, using more trips by micromobility, that means walking, biking, e-scooter, and spending more travel time in non-auto modes. From the results, we also found that higher frequency of work from home induced more daily non-work trips. This provides evidence supporting the rebound effect of telecommuting, implies that the trips that are foregone due to not commuting might be offset by telecommuters making additional non-work trips. And finally, we found that higher frequency of work from home is associated with less daily VMT. There are two key points associated with this finding. The increase in VMT due to the rise in non-work trips almost counterbalances the decrease in VMT resulting from improved travel efficiency, and the combined direct and indirect effects led to a negative effect of work from home on VMT. Here are the policy implications. So this study can help the policymakers to take post-pandemic transportation and work from home related policies, and the results will help to understand the impacts of work from home on 3 travel behavior indicators in a comprehensive framework. Here, the travel efficiency factor can be considered as a critical tool for controlling VMT. We can control the different indicators and see how it impacts the VMT. And this study offers valuable insights into the generic socio-demographic characteristics of workers who frequently engage in work from home, take more non-work trips, adopt sustainable travel modes, and generate higher VMT. There are some limitations in this study. The unavailability of detailed location data didn't allow us to test the impact of important built environment characteristics on different travel behavior indicators. And workers' occupation data was also unavailable in the NHTS data, which is considered as the important determinant of work from home arrangements. And future studies could focus on how household dynamics affect the relationship between work from home arrangements and VMT. And we could incorporate a detailed environmental assessment to measure how changes in distance travel due to work from home arrangements impact carbon emissions and overall environmental sustainability. So that's all for today. Thank you all. Thank you for here in the presentation.
Great. So it looks like we did have one question about seeing an increase in walking and biking trips, but how does that translate into miles traveled? And I can see Mike Highland had responded. They don't have active travel PMT in the model, and maybe this is something that we could look into. He says it doesn't have the relationship with active travel and PMT and telecommuting with them, but maybe Alex, if you wanted to follow up, there might be some more information available. Any other questions? Great. Well, thank you all for, I think, a great first day of BTR in the Western track.